Can you wait until after the lesson so you don't miss it? It's not a super long one today. It's like average. Which I guess it depends who you ask. Right now our proving skills, they're decent. Like we can use side angle side to prove some things, right? That's what we talked about last week. Side angle side. Right? Side angle side. Yeah. Remember? Okay, good. That's what we talked about last week. Now, today, we're going to add two more ways that we are able to prove that two triangles are congruent. Okay, so proving triangle congruence by SSS. What do you think that stands for? Side, side, side. Nice job. So we're going to be able to use side, side, side. The other thing that we're going to talk about is this hypotenuse leg congruence theorem. So that only applies with right triangles. So that doesn't come up like all the time, but it still will be helpful. So we have a theorem, example, and then another theorem and another example. So like I said,
do we need to write any of this down?
I would write down the theorems and the examples, yeah. So that's all of it. So our first theorem that we're looking at, 5a, the side, side, side congruence theorem. And that just says, if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So like it has here, this one might make a little bit more sense than side angle side even. But like it says, we have a side, and 1, 2, 3, and another side that are congruent. So if we can prove that two triangles have three sides that are congruent, then we're all good. We've got congruent triangles. That means the angles are congruent as well. Hopefully after doing side angle side, this doesn't seem overly complicated or anything too crazy. Because I think this might be easier than side angle side. Another 30 seconds. Found them?
Yeah.
So let's check out an example where we use this. Probably something that you could have guessed, right? Right to prove. We have our statements and our reasons. And again, if we're using side, 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 we need to prove that all three of the sides are congruent to three sides of the other triangle. So it starts out with the given. KL is congruent to NL, those are my initials, and KM is congruent to NM. So we already have, if we're trying to prove side, 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 we already have two of the sides, right? We have KL is congruent to NL, and that's given. We also have KM is congruent to
Wait, is that NL?
NM. Yes. Well, right here is NL.
Yeah.
Yep. This one's KM. And M is congruent to KM, and that is also given. So if we're trying to use side, side, side to prove congruence, we already have two of the sides. Now, what would be our last side that we need to say is congruent? LM? What is that congruent to? It's congruent to ML. How do we know that? What property. It's not given. Reflexive property, yep. Now, any line segment triangle is congruent to itself. So now, to wrap it all up, we would say triangle LKM is congruent to triangle LLN. This is because of side, side, side. I know we've only seen one example, but do we think so far this is easier or more difficult than side angle side?
Easier.
Yeah, I think it's a little bit easier. But yeah. Any questions on that first example? So not all of the questions that you see like this will be this straightforward, where it just gives you 2 out of 3 sides in the given, and then the third one's reflexive. But I think it still shows you how we will apply side, side, side. All right. Something that comes out in this lesson as well is if we can do side, side angle. I'm not exactly sure why they raise this question in this section, but what do we think? We just look at it for a second. Could we do? No, we don't do it right now. Could we do side, side angle?
Side, side angle.
Yeah. Do you think that would work? Look at these 2 triangles. They both have 2 pairs of sides that are congruent and a pair of angles, or one angle that's congruent. No, we could not do side, side angle.
It don't have that. Your writing is
No.
redo it.
No.
Redo it.
No.
Redo it. It looks so bad.
Writing's no.
Just write. Come on. Just a whole screen. Oh.
Lots better.
Lines. Circle.
There you go.
Exclamation point. Exclamation point. Yes,
No.
sir.
We cannot do side, side angle.
Those are
Doesn't
2
work.
completely different.
So maybe you just want to make like a quick note of that. We cannot do side, side angle, but
Explain the reason.
you don't even need to do that. I'm not sure. We can look at that after the lesson. I'll look at it after the lesson. We're almost done. All right, our next theorem. We have one more theorem, one example, and we're out of here. Well,
I'm not out of here.
out of the lesson.
Oh.
We have another theorem that we can use to prove that 2 triangles are congruent. Now, it only applies to right triangles. If I were you, I would write down the theorem name up here, and I would write down this picture. I would not write down this middle stuff. I would read it, but not write it down. Well, I guess I'll read it when I go over it. And don't worry about writing down this bottom stuff, because I will show you that as well.
What if we forget it?
Forget what?
What it is.
So that's why the pictures can help you, because you just have the statement.
What are we writing down again?
Write down the name of the theorem, right up here.
The definition.
Write down the picture of the triangles, and then these congruent statements down here. So this, that.
I'm gonna write down everything because I know I'll forget this.
You can, but I think those 3 things would be enough for you to remember.
How do I spell it now? Okay.
Do you guys have your schedule for next trimester yet?
Are we gonna?
Um,
Let me check.
I don't know.
Wait, so when is spring break?
Not anytime soon.
End of March. Another month.
You know where they decided to go? Connecticut.
Why Connecticut?
Why?
Of all places.
Is there family there?
No, I don't know why they want to go to Connecticut. I hope they're just joking because
What's
I
the-
didn't even know Connecticut was. I knew it was a thing, but like never.
Why do we even need Connecticut?
No, Connecticut's a small state.
Nah, you guys want to go to Rhode Island for spring
You
break?
want to go to Rhode Island?
Oh yeah.
For a second, I thought you said Rhode Island.
Rhode Island, yeah, let's
That's
go
the
there.
whole world.
They would be out of business, I guarantee. There's a place called Rhode Island. Right now, they'd be done. Everyone would be moved out.
Can I write HL for?
I don't have my classes
Yep.
yet. I don't have abbreviation.
If you'll remember hypotenuse leg,
Okay.
which we're going to label those terms on our picture, so that will help.
If they ask us for a theorem on like an assignment, can we just write the HL theorem?
Definitely. Yep. You can, just like you could write SSS, you can write HL here. Now, on like a test in the drop-down menu, I would never put HL theorem. I'd put hypotenuse leg, so as long as you know that,
Yeah.
that'd be good. But I wouldn't try to trick you. I would put like I wouldn't put like different words instead of HL. I don't know what the word instead of H now.
You would 100% do that.
It would be kind of funny if I put like hypotenuse leg as an option and then like
Hypotenuse.
hyper length or something. I don't know.
I'd be in a pen.
That'd be kind of mean though.
If you're mad enough, we'll do it.
I could put it because you should know that's not hyper length.
That's what Mr. Stowe does.
Like just stuff that doesn't make sense.
Yeah, like every once in a while on his test, he'll just see a completely random question.
Yeah.
Mr. Drangledar was fond of doing that too.
All right.
Like all the time.
So hypotenuse leg. Whoa. Hypotenuse leg. First, we need to get some terms down. The hypotenuse. Well, I'll ask you guys. Do we know what the hypotenuse of a right triangle is?
The line. The line.
You both are correct. It is not a leg, but it is the
The line connecting.
yeah. So it is an easy way to remember it. It's the line
Connecting.
right across from the right angle, or it connects the two legs. There's a lot of ways to think about it, but this would be the hypotenuse.
The slide
Right here.
of the triangle.
It's the longest side of a right triangle, right across from the 90-degree angle.
Looks like a slide.
Yeah. It does. The leg, or the I guess there's two legs,
There's no legs.
would be the two
The triangle.
sides that form the right angle. So there's a little bit more vocab right there. The hypotenuse is right across from the right angle, and the legs form the right angle.
Wait, so it's actually called hypotenuse leg.
But it's legit. I'm not messing around.
Legit.
Legit. So, there's our vocab. Now, like the theorem says, if we have the hypotenuse and then one leg that are both congruent in the 90-degree angle, then we have congruent triangles. Okay? Because we have the right angle and a hypotenuse in the leg. Oh. I see. That's very clever. Technically, if we were to call this something else, this would be the side-side angle, wouldn't it? The side-side angle theorem, right? Because we have a side, and an angle. But this only works if it's a right triangle. So that's why we first go over, do we have side-side angle? No, we don't. But in a right triangle, we can have the hypotenuse and a leg. That's very, that's good. I see what it's like. That's good thinking. Textbook got me on that one. Do you understand that? Like we talked about, this example, we have a side, an angle, and then a side, but these are not congruent triangles. No. Here we have, again, a side, and then an angle, but we do have congruent triangles. And that's only only because it is a right triangle. So this only works with right triangles. That's why they call it the hypotenuse leg, because that applies to right triangles. So if we were looking at a proof, the one thing that we probably would want to do here that could be helpful would be to draw this picture again, because I think when these are drawn like this, they can be really confusing. So if we have W, Z, Y. Could redraw and have X.
What do your Z's mean?
Oh, I did something backwards. Something I did backwards because our Z's don't match up. Let's see.
Z is supposed to be where Y is in the first one.
Exactly.
Wait, no.
You don't think I should?
No, it's because it's not the other way.
W, Z, Y.
Yeah, and then the
Oh,
triangle's
it was
the other
good.
way.
Yeah, we were good. See, that's why I shouldn't.
Why is it that way if the triangle's not?
It looks like an N.
Because
Flip the other way.
think this would be flipped around.
Yeah.
So you're saying you want me to draw like this?
Like the way it is.
Does that work better?
Yeah.
Okay.
Look, it's
So
like
if we would have these as our last example, if we have triangles that are crossed like this, an easy thing to do might be to redraw them. Now in the proof, they say WY is congruent to XZ. So that is congruent to that. WZ WZ is perpendicular to ZY. So if two lines are perpendicular, what does that mean? What angle degree do they form? Perpendicular lines. What? Yeah, 90 degrees. So they're telling us we have a 90-degree angle here and a 90-degree angle here. So you need to prove that two triangles are congruent. So first, let's start out with the given. WY is congruent to XZ. That is given. And if we're using the hypotenuse leg theorem, that gives us the hypotenuse part of it, right? Right? That gives us the hypotenuse part of it.
Yes.
Yes. Now, when we're using these hypotenuse leg theorems, even though they told us in the given that we have right triangles, we still have to state in our proof that we have right triangles. So we need to say WZ is perpendicular to ZY, and XY is perpendicular to ZY. So we still need to say that we have right triangles. This is given. And because of that given information, we can say that we have right triangles. WZY because this is with the definition. So in the given, they tell us that WZ bisects, well, is perpendicular to ZY, like what we put right here. So we need to state that, and now we need to say, because of that information, we can say that these two triangles are both right triangles. Are you guys following? Are we good?
Yeah.
Now, we're trying to use the hypotenuse leg theorem to prove that these triangles are congruent. We already have the hypotenuse. Now, how do we prove that we have congruent a leg that is congruent? And which leg would it be? Remember, the legs are the sides that create the right angle. So what legs are congruent in these two triangles? That is true, but I don't know if we could prove that. Which legs are congruent that we could prove? Yep, ZY and YZ, right up here. ZY is congruent to YZ. We know this because of the reflexive. Because remember, and this is why it's important that when we redraw our triangles that we label them correctly. But remember, in the original right here, they share that side. Now, to sum it all up, to bring it all together, like the last step of all our proofs, we can say triangle WZY is congruent to, and I'm writing this on their side so I ran out of space. Triangle WZY is congruent to triangle XZY, and this is because of the hypotenuse leg. Hypotenuse leg. There's a little bit more to that one. But what it comes down to is when we see triangles that are, they either tell us right away that they're right triangles, or they tell us up here in the given that we have perpendicular angles, then we should probably take a hard look at using the hypotenuse leg theorem, because that is the way that we would prove that two right triangles are congruent. Alright? So, we looked at the side, 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 proving two triangles are congruent using side, 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 and then using this hypotenuse leg. So now we have three different ways that we're able to prove triangles are congruent. Side angle side, 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 and HL. There's a practice problem. Notice they tell us that we have right angles, and it shows it down here. So that means that you should write your proof using hypotenuse leg theorem. Prove that those triangles are congruent.
Just like this one.
Well, you have to do this one.
Oh.
It's your practice problem. You have to work through it. Yes, you can. Thank you for waiting.
Okay.